potassium manganese 7, okay, is a very powerful oxidizing agent here. Okay, so come back to here. Okay, the main point is the manganate 7. Manganate 7, the formula here is the Mn. Mn is the manganese. Okay, manganese here. This one, manganese is a transition element here. So the MnO4 negative is the manganate 7. Potassium, of course, is the K. So the main point is not the potassium. It's actually the manganate 7. And the formula is MnO4. And then based on this formula, the manganese is actually at 7, at positive 7. Okay, we do a bit basic one. Okay, we count the oxidation number for the manganese, the Mn. So Mn, let's say we do know the answer. Then for the oxygen, common one, for one oxygen, the charge is 2 negative. Oxygen, when come to the ion, O is 2 negative. And now you got 4 oxygen. Okay, you got 4 oxygen. So 4, 2 negative. Oxygen is 2 negative, right? So you got 4. So 4 times 2 become negative 8. This is our previous syllabus, the lesson. So the oxygen alone got 4, means it's negative 8. And the Mn, we don't know the answer. But these two combined, the total answer equals to negative, right? Is the negative 1. It means you do a bit max here. Mn is like unknown answer. Then plus 4. Why is 4? Because oxygen got 4. Oxygen, the charge is negative 2. So don't know the answer, so I put x plus 4 negative 2 equals to negative 1. So what is the answer for x? 7. One more time. Mn here, we don't know the answer, I put x there for max. Plus, got 4 oxygen, so I plus 4. The 4 there I put bracket negative 2. Why negative 2? Because of the oxygen, the charge is 2 negative, so it's negative 2. And the overall MnO4, the overall charge is negative, means negative 1. So the total charge is negative 1, right? So I put Mn is x plus 4 bracket negative 2 equals to negative 1. What is the answer for the x? Answer is 7. It's the positive 7. It means the manganese, the oxidation state for the manganese answer is 7. Is here. The manganese is in oxidation state 7. That's why the name is called manganate 7, because of the manganese under the oxidation state is plus 7. Okay, but the point, okay, of course the overall formula for the potassium manganate 7 is K. The K is for the potassium. Then the MnO4 is the manganate 7. So combined is the KMnO4. This is the formula for the potassium manganate 7. And what is the color for this chemical? Is purple color. It's already here. Maybe you look a bit dark here because when I scan, may not be that perfect. You can look at your own textbook. You can see it's dark purple. So yes, it's dark purple. When very dark, close to the black, but it's not black, it's dark purple color, strong purple color here. Okay. Okay, continue first. So now in this formula KMnO4, okay, the oxidation state for the manganese, the Mn is 7, is positive 7, is plus 7. But for manganese is more stable in the oxidation state plus 2. Okay, look at here. If at first starting is plus 7, okay, for the manganese is plus 7, the oxidation state is plus 7, but it can become the plus 2. From plus 7, positive 7 become positive 2. Is it going down? When the value going down means the value reduced. From plus 7 to plus 2, value reduced, means it's undergo reduction. When this one undergo reduction, is the oxidizing agent. Okay, the one that undergo reduction is the oxidizing agent. Look at this question. The MnO4 negative, undergo reduction, become the Mn2 plus, because 2 plus is the oxidation state plus 2. And for this one, for manganese, is more stable compared to the manganate 7 ion here. Once reduced to this one, is more stable. It's better for it. Okay, so undergo reduction means it's a oxidizing agent. Okay, so it's strongly driven to reduce the oxidation state to 2 by gaining electron. This is why potassium manganate 7 act as a powerful oxidizing agent. So for, come back to here, the answer. Okay, explain why potassium manganate 7 is a powerful oxidizing agent. Okay, the main answer is strongly driven to reduce its oxidation state. Okay, it's strongly driven to reduce its oxidation state to plus 2, which is more stable by gaining electron. This is actually the main answer is the last sentence here, because the manganese, okay, the 7 is not so stable. If can reduce into plus 2 is the best. Okay, it's strongly driven to reduce its oxidation state to plus 2. So it's a powerful oxidation. This is already the answer. Okay, and then got one more. Okay, how about the potassium iodide? Is used to test oxidizing agent. So potassium iodide is used to test for oxidizing agent. If I say potassium iodide is used to test for oxidizing agent, means this potassium iodide must be the reducing agent first. Okay, one more time. Potassium iodide, explain why potassium iodide is used to test for oxidizing agent. Okay, means something undergo reduction. It means this one must be the reducing agent. You want to detect something is oxidizing agent, you have to use the reducing agent. You want to test for the reducing agent, you must use the oxidizing agent. It's the other way only. But because must be one oxidized, one is reduced, then it is called the redox. Okay, so explain why potassium iodide is used to test for oxidizing agent, because this one is the reducing agent. Okay, look at the test. Test book here. Okay, potassium iodide. Okay, it's a reducing agent here. Example here, when potassium iodide solution is added to hydrogen peroxide, the H2O2 here, in the presence of sulfuric acid. This is a redox reaction. The main point is we have to look at the potassium iodide here. Look at the I. The I here is actually the I negative, because the K plus and the I negative combined is the Ki, potassium iodide here. And the end product after the arrow, the I here become the I2, means it's the iodine. And iodine here, what is the color? Is red brown color. Okay, and for the potassium iodide, got color? No color. When come to the lab, let's say why, okay, let's say just now the one, why we like to use potassium manganate 7 as an oxidizing agent? Because original color is the purple color. Once it's reduced into the manganese 2, it will turn to colorless. Once got the color change, then only we can observe the result. Okay, we can observe the thing change, right? Once got color change, then we can see. Once we can see, only we can record for our experiment result here. This one also the same thing here. At first, the Ki got no color, but once it's oxidized become iodine, it will turn to the brown color. Means brown color means it's already oxidized. Means got chemical reaction here. Understand? Okay, one more time. So now the main point is the potassium iodide here is actually the I negative and become the I2 is neutral. So from -1 becomes 0. -1 becomes 0. The value increase, right? So this is actually oxidation. Because the Ki, the main point is the iodide, not the K, is the iodide, become the iodine. So when this one iodide is oxidized to iodine, it itself undergo oxidation. This one must be the reducing agent. When I say the Ki is the reducing agent, automatic, the H2O2 is the oxidizing agent. Okay, the H2O2 is the oxidizing agent. So basically, we must use something called reducing agent to detect the oxidizing agent. Let's say, if I want to check for the oxidizing agent, I have to use, I want to check for the oxidizing agent, I must use reducing agent. You want to check for the reducing agent, I must use oxidizing agent. Must be the other way. Okay, okay, so the answer is already there. So I stop first.